Hey guys, this is Mrs. Schoenberg. This is lesson 7.8. This is a couple pages of a lesson. This is linear inequalities in one or two variables. Well, first off, when we talk about what is an inequality, it's something like 2 is less than 5. And once we get into algebra, we can, you're going to see a variable in that, like x is less than 3. And really what this means is x, the solution to this problem, is any number that is less than 3. That's what this would mean. X is less than 3. Any number less than 3 would satisfy that equation that we're looking at. What are the inequality signs? This one was greater than. This one is less than. And then if you have the greater than sign with half of an equal sign underneath it, it's greater than or equal to. And then the last one is less than or equal to. Less than or equal to. How do you read a linear inequality? Really like you read a book from left to right. So if you do have x less than 6, you would just read it with x is less than 6. Okay. Isn't there a special rule about flipping the sign? Yes. I'll remind you when we get there. But when we do any type of multiplying or dividing by a negative, you are going to have to flip the inequality sign. I'll remind you of that when we get to some of these practice problems. Okay, so linear inequalities, these are inequalities of the given form. A, B, and C are real numbers, and A cannot equal 0. So they look something like this. Here's an example. 6x plus 8 is less than 32. Okay, that's an example of our linear inequality. And we have worked some of these. We have solved problems like this. Instead of this inequality sign, there was an equal sign. And to solve it, we would subtract 8 from both sides, then divide by 6, which is really how to solve this one. First, you start by subtracting 8 from both sides. And then you have 32 minus 8, which is 24. Then I'm going to divide both sides by 6. X is less than 4. So for this to be true, for this original linear inequality to be true, the number x, anything less than 4 would make this true. 3, 2, 1, 0, negative 10, so on and so forth. Even a decimal like 3.9 is less than 4. So that's a first look at these. Here's some rules for solving linear inequalities. First, simplify each side by removing any grouping symbols, and as always, combine your like terms. Then use your addition property to add the opposites. Same thing with subtraction, and then multiplication or division to get that variable on a side by itself. Okay. Then a quick check is select any one number in your solution and substitute it in to see if it's a true statement. So starting with this one, x plus 3 is greater than 10. We're going to subtract 3 from both sides, and we have x is greater than 7. Okay? So the solution set x is any number greater than 7. If I was in the classroom, I'd say, give me a number greater than 7. Someone might say 100. Put in 100. 100 plus 3, is that greater than 10? Yes. Try 8. Is 8 plus 3 greater than 10? Yes, because 11 is greater than 10. Okay, that's how you could check it. This one right here, we're going to start by subtracting 5 from both sides. Again, trying to get the x on a side by itself. Minus 10 minus 5 is minus 15. Then I'm going to divide both sides by 5. So x is less than or equal to negative 3. Done. You could check answer there if you wanted to. this one. Look on both sides. Is there any like terms you could combine? Yes, we're going to combine this first. So what I'm really dealing with is 5x plus 5 is greater than, that's a negative 10 plus 8. So that's negative 2 minus 4x. Now I'm going to get all the x terms on one side. So I'm going to add 4x to both sides. So I have 9x plus 5 is greater than negative 2. And then I'm going to get the non-x terms on the other side. So 9x is greater than negative 7. I'm going to divide by 9. So x is greater than negative 7/9 on that one. That is the answer there. Okay, this is one where we're going to have to start paying attention to when this special rule right here. If we are dividing or multiplying by a number that has a negative, then we're going to flip the inequality sign. So far, we did some subtraction, and but we have never divided or multiplied by a negative yet. So let's pay close attention on this. I'm going to start by subtracting 3. So I have negative x is greater than 10 minus 3, which is 7. Now, you can think of this a couple different ways. You can think of it as dividing by negative 1 or multiplying both sides by negative 1, but we have to get x on a side by itself. So when I do that, a little alarm should go off on your head, like beep, beep, beep. We got to flip the sign here, okay? So this is going to be x is less than negative 7. 7 divided by 1, negative, is negative 7, okay? And that's the answer. Okay, let's do another one. Let's subtract 5 from both sides. So now I have negative 5x is less than or equal to minus 10 minus 5. It's minus 15. I'm going to divide by negative 5. Beep, beep, beep. I need to switch the sign here, and that's 3. So the solution set here is x is greater than or equal to 3, meaning you could pick any number greater than 3, actually even equal to 3, and it would make this true. If we put in 3 for x up here, negative 5 times 3 is negative 15. Negative 15 plus 5 is negative 10. Is negative 10 less than or equal to negative 10? Yes, negative 10 is equal to negative 10. Okay, so that's how that works. This one you want to probably pull out your calculator, but right off the bat, I'm going to divide both sides by negative 3. Beep, 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 beep. And then 12.3 divided by negative 3 in the calculator is, let me switch my sign here, negative 4.1. Okay. Now, when you're entering these into Hawks, remember to use the keypad to find your inequality signs. This one right here, it's not too bad. Let's just see that we have to subtract 4/5 from both sides to get t on a side by itself. And so we end up with 1/5 minus 4/5. If the number on the bottom is the same, if the denominator is the same, you can go ahead and just do the math on the top. So 1 minus 4 is negative 3, and it's negative 3/5. Okay, there are two special cases that you'll come across in this lesson. If you do all the math and the variable goes away and you end up with something like this, 0 is less than or equal to negative 5. Okay, 0 is less than or equal to negative 5. That can never be true. Okay, you would choose the no solution option in Hawks. If you did all the math and for whatever reason the x's canceled each other out, came to 0, and you end up with something like this, 0 is less than or equal to 5, and that is true. That's always true. And your solution set here would be all real numbers, all real numbers. Okay, going on to page 2. Again, we are still in 7.8. First, we did the review of these linear equalities, and now I need to tell you about algebraic notation and interval notation and how to graph these. So, first off, what is the difference between algebraic notation and interval notation? Well, for algebraic notation, It's what you've been used to so far. So algebraic notation looks like this. You're still going to see the variable. Okay, you've done the math. It's what we did on the prior page. X is less than 3. That's if the instructions in Hawk say, please put your answer in algebraic notation, you would do this. Okay. But some of the Hawks is going to say, put your answer in interval notation. And in interval notation, there's really no variable. It's going to look something more like this. Say 3, 2, 5. Okay, and I'll explain what some of these extra symbols mean here. Also, we're going to come across needing to know what to do about infinity. So infinity, if it is positive infinity, on a number line, it's always going to be to the right. Okay, and at times we're going to deal with negative infinity. And negative infinity is always to the left, and it has a negative sign in front of it. Okay. Now, if I asked you this in class, are we ever going to hit infinity or negative infinity? You would say no, we're never going to hit it. It's just out there. In that case, it's never going to be equal to infinity. Okay. You'll see what I mean here in a minute. All right, let's review. Let's put some real numbers into this. So if this was our algebraic notation, this is called an open interval. If the solution x is greater than 3 but less than 5, here's what the interval notation would look like. 3, 5. And here's what the graph of that would look like. Now let's say we have 3, we have 4, we have 5. It would look something like that. This connects to that. Okay. Now, this one has one closed interval. Let's use the same numbers. 3 is less than x, which is less than or equal to 5. Okay, so here's what interval notation would look like for that one. 3, comma, 5, bracket. And here's what the graph would look like. Let's say we have our 3, our 4, our 5, bracket, open parenthesis. Okay, do you see the difference? We used a bracket when the sign is less than or equal to. It can be equal to 5. So this bracket signifies that the solution set could include 5. Okay, and whereas the 3 is more for less than or greater than. Okay, this next one, we're going to skip this one because it's pretty much what we just did. Let's look at the open interval, meaning the solution set here, let's say x is less than 5. X is less than 5. So here is what the interval notation would look like. Negative infinity, comma, 5 is the interval notation. So what we're saying here is that the solution is any number less than 5, any number forever and ever and ever less than 5. So since x is less than 5, we're going to go negative infinity, comma, 5. Sometimes I like to actually graph it before I go back and do the interval notation. So 5 would be our important number. It cannot be equal, so we're going to do that. And it goes all the way to negative infinity. So the solution set here is negative infinity to 5. Okay, and let's do one this way. Let's say x is greater than or equal to 3. Again, sometimes I like to graph this first. So the solution set is anything greater than or equal to 3. So 3, can it be equal to 3? Yes. Anything greater than or equal to 3 all the way to infinity. And since we can never equal infinity, we're going to have an open parenthesis there. So going back to do the interval notation, looks like that. Now I will say sometimes you'll mess up on a few of these. You'll forget to put the negative infinity. So when if it's less than, it's always going to be a negative infinity. If it's greater than or equal to, it's going to be this positive infinity. You might mess up on a few before you really get these straight. Okay. Let's work out a few of these and then you'll be good to go. 6x plus 5 is less than or equal to -1. And I will say when you get into the hawks on this, sometimes this is step 1 and then step 2 and then step 3. And it's like solve the inequality, graph it, and then what is the interval notation? So I go ahead and do all those 3 steps at once, and then I have it ready to go for my problem. So let's get this thing solved, this inequality. I'm going to start by subtracting 5 from both sides. So I have 6x is less than or equal to -6. Then I'm going to divide by 6, and I have x is less than or equal to -1. I like to go ahead and graph it second. So the important number here is a -1, and that's really the only thing I need on my number line. The solution is anything less than. And if you have this x on, if you always solve the inequality and you have the x on the first side, the inequality sign actually acts like an arrowhead into like which way this should point. Okay, so it's going to point this way. So notice the arrowhead here and here are the same. Now, can it be equal to -1? Yes, so that's going to be a bracket. Can it? This is always going to be negative infinity going this way. Okay, so then my interval notation is -infinity, comma, -1. Okay, this one here, let's get my x's on a side by itself. So I have 1x minus 3x is -2x. Let's add 3 to both sides here. Looks like I'm going to have a fraction on this one. And the fractions are fine. X is greater than -7/2. The fractions are fine. Sometimes when you go to graph them, they become a little bit challenging, but you kind of have to find out where -7/2 is on your number line. And this solution is cannot be equal to that. And it is anything less, oops, I did that one. Guess what Mr. Schoenberg did? You probably caught me, but I did not flip my sign when I divided by a -2. So we're going to change that to flipping the sign. And then I have that correct. So the interval notation is -infinity, comma, -7 halves. Okay, again, don't be like me. Flip the sign when you divide by a negative. Last one, here we go. Let's get the x's on a side by himself. If I have 6 minus 5x is less than or equal to 1, then I'll move that over there. So I have -5x is less than or equal to 1 minus 6 is -7. How about 1 minus 6 is -5? There we go. Then I'm going to divide both sides by -5. Beep, beep, beep. I'm going to remember this time. X is greater than or equal to +1. Okay, let me just check my work here real quick. Minus x, minus 4x, minus 1x is minus 5x. 6 minus 5x is less than or equal to 1. Minus 6, 1 minus 6 is -5. Divide by -5, +1. Okay, then if I do my graphing, and my important number here is 1. Can it be equal to 1? Yes. And then x is anything greater than all the way to +infinity. So my solution set is 1, comma, +infinity. All right, that should do it for 7.8. I hope that helps and really explains the, read the instructions. Make sure you're seeing if it says algebraic notation or interval notation. That's the biggest question I get on students. They think there's something wrong with Hawks. They're entering their answer and it's not letting them. But it really, make sure you're reading the instructions and entering what they ask. So I'll post this out on Canvas. I hope it helps.